So in this case, we are going to consider working with our stress on our strength of materials. But in order for us to do understand that in practice, I just need us to go through some type of forces. Because as you consider the stress, it is taken. I'm going to talk about this part here. Remember, major part of our class is to work on the stress. And we are given this, the stress represented by the symbol sigma, which is equivalent to the load, which is the force, over the area. So you're considering what is the load or what is the force there. Okay, so you're considering what is the load, which is your force. So this force is actually the load that you're given, and we are referring to our area, which is measured in square meters. So this is going to give us the stress. And from these calculations that we are having, it is measured in pascals. So we're going to relate, is it the kilopascal? Is it the megapascal? Supposed to be in Pascal. So because of the load, which is the force, being different, the force or the load being different, this is where now we are brought to the types that we are given of the forces. If there is a tensile force, like what we have on A, where we are given a tensile force, the one that stretches the material, we're given this force going this and this one, apply this other, stretching the material. That's a tensile force. So meaning to say, we are going to consider to say if the force is a tensile force, therefore what are we calculating? The tensile stress. It is just the same thing. Working with a compressive force, where there's a compression, object is being taken to be small, force is being applied like that. Compressive force, meaning to say we shall be talking of what? The compressive stress, the type of force that is given there, type of force. So this one, we can just refer it as a direct, just direct stress. So like I said, the type is determined or is taken from the type of force that is being applied. That is the one that is going to affect the stress that we have. So talking of the compressive force, we're going to talk of the compressive stress. So that is, we're going to talk of the tensile stress, the compressive, the shear, the crushing stress, depending with the force that is being applied. So with your unit of convergence area to the square meters, you can calculate whatever that you're given, manipulating what you're given, the object that you are given there on the surface. What type of an object? Is it a rectangular object? Is it a square object where the area is going to be length times the base? Is it a circular object that you are working with? Wherever there is a circular portion, meaning to say the area of that circle that you be given will be taken from what? Pi d squared over 4. Is it a condition that you have got something of an annulus condition where there's a smaller diameter inside and there's a bigger diameter of the outer circle? The area is going to be taken from pi over 4. Then we are going to have d squared minus d squared. Depending with the area, what is it that you're given? The shape that will affect your area in square meters, and also those conversions, as you heard from your engineering science, they do not change. Conversions of units, the millimeters to meters and this and that. So questions will be asked where you need to manipulate the formula or to just use the formula direct. Like I said, depending with the type of force that you're given, you can calculate the given stress. On this first example that we are given, we have a bar made of steel supports a load. So it supports a load of 20 kilonewton. if the bar has a diameter of, we are given this bar, it has a diameter, meaning to say we have got something that is what? Circular. There's a circle that we have to consider. So that's why we are given the diameter. Calculate the tensile stress because of the force that is being applied, the load, that is the tensile force. So we're gonna calculate the tensile stress. But the formula, guys, is not gonna change. Just write your formula. It's the stress that you're calculating. So it is what? Force over area. Just like that. So the load is our force. So we're given there the load, which is 20 kilonewton, and we have the diameter in that case. All right. So our diameter, which is 15 millimeters. So as we know our conversion to the meters, you can divide this by 1000, or you can simply multiply the milli there, simply means times 10 to the exponent of minus 3. Or you can simply divide by 1000. So that is your diameter there. So you can just multiply by 1000 or just leave it like that, which is going to be something like 0,015 meters. This is your diameter. So definitely, as we are to calculate this, we are going to need the area. The area of a circle. Like I said, that is what? Pi d squared over 4. We have the diameter, so that is pi times the diameter, 0,015 squared over 4. So this was going to give us the area, or you can just substitute here as it is on the formula, which is fine. Because you have the formula for the circle, for the area, so you can just manipulate that, okay? I'm going to show you that way. So you can calculate the area aside. So that was going to give you a lot of zeros there. And with this area, so we've got something like 0,000 1761458. Definitely you're going to have a lot of values, and if you check, there are so many zeros that we have. So what you can just do is to move to a certain comma. You can even move and maintain any decimal that you want. So, and as long you're working with the whole numbers there. So some that you can maintain times 10 to the exponent of minus 4 times 10 to the exponent of minus 6. It's going to depend with your simplification. This is what I'm trying to say. As you move the commas, this is going to be 1, 2, 3, 4. We have got a whole number there. So you can even move up to that point where you can see a whole number. That's it. So A is going to be what? 1 comma. So it's now 1 comma. There's a comma there. So it's now 1 comma 7, 6, 7. Okay. So that is what you can have. How many commas did we move? We moved 1, 2, 3, 4. So that's times 10 to the exponent of minus 4. Remember, guys, your concept of changing to this format of the standard form from a decimal. That's a 0 there. So as long you've got a 0, this exponent is going to be a negative. So that's our area. This area is in square meters. So meaning to say we're talking of what? The square meters. If you wanted, you can even use until a minus 6. That means we can move 1, 2, 3, 4, 5, 6 up to this point. It will be better that way because it helps you now to maintain in terms of the answers, at least your answers to be in a certain range. So that one, do not worry. We use the value that you have obtained there, the way that you have written as it is. So you can substitute this here, force. Remember, we're already given, we have our force 20 kilonewton. So that is 20 times 10 to the exponent of 3 over the area that you calculated, 1,767 times 10 to the exponent of minus 4. So this will give us the tensile stress. From this, you're going to obtain the tensile stress. So that was going to be 113.619.1,3 Pascal. So you'll see that as you are working with the stress, the tensile stress, all these basic stresses that you're going to work with, it is best that you write your answers in megapascal. In megapascal. Remember, mega means what? Times 10 to the exponent of 6. So in order for you to convert to the megapascal, you do the opposite of this. This is exponent of 6. So what is it that you do? You simply multiply by the inverse of it. You multiply by 10 to the exponent of a negative 6. This is to convert to the megapascal. You are converting to the megapascal, meaning to say whatever that you're going to obtain, once you multiply by 10 to the exponent of minus 6, whatever that you're going to get will be in megapascal, whatever that you're going to have. So what is it that we are going to have? And that part is going to be in megapascal. We are going to obtain 113, 186. It's going to be like this, 186. This answer that we're having is now in megapascal by multiplying by this. We are converting to. You do introduce a negative there, meaning to say the vice versa is true. If you want to remove the mega, how do you remove this? You multiply by 10 to the exponent of 6. You are removing this megapascal, writing it as just Pascal. So it's the opposite. The same thing, guys. You want to convert to the kilo. If it is kilo, whatever that you want, you just use the opposite. You multiply your answer by 10 to the exponent of minus 3. Your answer will be directly in the kilo that you're given there. Introduce a negative, the inverse of that. So that was going to give us the stress, which is the tensile stress. And as you have to consider this, in an exam condition, you can just simplify, because if you check there, you have to round off that area, this and that, and a lot of conversions that you have. And in that process, we can simply say, since we do know this area, we can simply take this formula at once. The stress is equal to the force, which is true, over the area. What is our force? Our force is 20 times 10 to the exponent of 3. And what is our area? Our area is given by pi d squared over 4, which is this one. So we can simply divide this by the area, pi times 0,015 squared over 4, like this. We can simply calculate and obtain the answer. And like I said, since you know, now you know that you're calculating the stress, which is measured in Pascal, and you're going to have these bigger values that are to be converted to the megapascal. So if you do understand that, what are you going to do? On this part, you just have to multiply everything that you're getting from your answer. Multiply it by 10 to the exponent of 6. What are you doing by multiplying by 10 to the exponent of minus 6? You are converting your answer to the megapascal, meaning to say whatever that you are going to have here, whatever that you're going to have here is going to be in what? In megapascal. That is how you can simply have your answer now. So meaning to say, that was going to give us 113,177 megapascal. This is what you're going to have. So you see now that part of the rounding off of the area, it is affecting a little bit on our answer there. So in order for you not to have your answers affected and have a direct answer, it will be best that you just substitute direct like this, because this is the exact answer that you're supposed to be getting. And also on this conversion, on this writing of your area, if you want to have a little bit your values to be exact, you can choose to use exponents, like to the exponent of minus 6. Instead of using minus 4, you can choose minus 6, minus 7, anything like that. So this is what we have. But do not worry about these values. The way that you round off, please do write your answers that way. On the other part, you are given. Let's consider this question. Just hope it's going to be clear. What diameter mild steel rod is required to carry a pulling force? Take note, pulling. What is it that you're considering? Pull. Meaning to say you're taking this and you're taking this other one. That's tensile force. There's a tensile, but do not, even if you do not know the type of force, guys, the formula does not change. It's force over area, whether you know the type of force or you don't know. Okay, so we've got the tensile force, which is the pulling force. That's why even they're asking us to say if the tensile stress, they give us that. So in this case, we've got the force. All right, so let's take our information or the data that we are having there. We have the force is given 120 kilonewton. And if the tensile stress in the steel is not to exceed, meaning to say that's the maximum that we can have, that is the maximum. We are given that stress. It's not to exceed that. Okay, so our stress is given as 62 megapascal. They want you to calculate what diameter is it that you are supposed to have. What is the diameter? By looking into our formulas, we can see that there is no formula that connects the force, the stress, and the diameter. No. There's no formula that connects, because we do understand that the stress is equal to the force over the area, not the diameter. But they want us to calculate the diameter, not the area. So the question is, where are we going to have it? Because this formula does not have the diameter. There's no diameter, as we can see. It is inside of the area. That is where the diameter is, because we do understand that it's a circular rod that you're talking about. So the area is going to be taken as pi d squared over 4. So from there, we can understand that the diameter can be obtained. You can just make it the subject. Okay, let's make diameter the subject. In this case, I'm going to cross multiply. And now back to your mathematics. 1 times this, pi d squared, that is going to be pi d squared is equal to 4 times a, which is 4a. And now back to your mathematics N4, change of subject, maths N4, maths N3. Okay, let's divide by pi. Introduce the square root to remove what? The square. So we're going to introduce the square root of everything. So meaning to say that's canceling this squared. So the diameter must be taken from the square root of 4a over pi. This is where the diameter is supposed to be taken from. So it means in order for us to have this diameter, there is a need for the area. We do not have that. So where are we going to obtain the area from? That is where this formula now plays a role in calculating of the area. So let's find area here. Make A the subject. Okay, let's make A the subject. So if you make A the subject, this is over 1. So guys, we can simply cross multiply. That's phi times A is equal to F. What is that we need? We need A, so you can simply divide by phi, which is our stress. So this was going to cancel. So A is equal to the force over the stress. So you can simply substitute now this and calculate our area first. What is our area? The force is given 120 kilonewton times 10 to the exponent of 3 over the stress. What is our stress? 62 megapascal times 10 to the exponent of 6. To remove this, you multiply by 10 to the exponent of 6. You are not converting to, you are removing the mega. So what is the equivalent of the mega times 10 to the exponent of what? Of 6. So this was going to give us the area. In that case, it was going to give us a decimal. Like I said, you know, these decimals, guys, it was going to be 0, 0, 0, 1, 9, 3, 5, 4, 8, 3, something like that. It's your area, this one, in square meters. So you can even just try, write this. You can just move the commas there, 1, 2, 3, depending with what you want. You can even move up to 6, like 3, 4, 5, 6, so that you can at least you have values that are exact. Depends with what you understand. You can move up to this comma, because that even a textbook, you see, sometimes they use times 10 to the exponent of minus 3, sometimes times 10. So use what you understand, okay? So this will be 1, 9, 0.35. They have 3 digits after the comma there. All right, times 10 to the exponent of what? I moved 1, 2, 3 commas. So that's to the exponent of -3. So this is the value of the area that I'm obtaining, or you just store that answer on your calculator and use it as it is here. Just on your calculator, you have the square root of 4 times. In place of this, you just put the answer as it is from your calculator, the answer as it is from the answer button of your calculator. That can be easier that way. You obtain exact. That is if you want to obtain exact values, but I'm not saying this is wrong. They are going to mark these values that you're obtaining according to the way that you're rounding off these values, right? We have the area. This is the missing part that we need to obtain our diameter. So therefore, the diameter can be obtained. The square root of 4 times the area. Remember, we got 1,935 times 10 to the exponent of -3, everything over what? Everything over pi. The square root, guys, is covering, even the pi is under the square root. Even the pi is under the square root. So this is going to give us the diameter, definitely in meters, 0,049635, something like that in meters. Why am I saying in meters? Remember the area as we are using it on this formula, it is in square meters, square meters. So meaning to say the diameter will be in meters, but you can convert this to millimeters the way that you want. Because these are meters. How do you convert to millimeters? Remember, in a meter, we've got how many millimeters? 1,000 in that case. In a meter, we've got 1,000 millimeters. Remember, milli means times 10 to the exponent of -3. So this cancels to give us a meter. So if there are 1,000, we simply multiply by 1,000 to convert to the millimeters, or you multiply by 10 to the exponent of 3 to convert to the what? To the millimeters. So therefore, you can just have your diameter as, if you multiply by 1,000, that was going to be 1, 2, 3, something like that here. So it can be 49,635 millimeters. If you want to have it that way, or you can just leave your answer as it is to say the diameter is equal to this in meters. So it's just manipulation that you'll be having on your formulas. So these basics, they are going to help us as we advance. These manipulation, that is the part of your strength of materials. Manipulation of the change of subject, this and that. So you have your diameter there. Another question you're given, what is the maximum load? Maximum load, you're talking of the force to be applied that can be carried by a hollow cast. This is a hollow cast. It's a hollow cast iron that you're given, meaning to say there is something inside and other part outside, the diameters, inner diameter and the outer diameter. Remember, I talked about these areas. When you're given this type of a hollow section, the area is going to be pi over 4 into d squared minus d squared, where d is the one for the outer circle. And this small letter d is the one for the inner circle. So this is the condition that you are having. So they are giving us, it's a hollow cast iron column of outside diameter. The diameter that is outside, that is the capital letter D. The outer diameter is the one that carries the D. The smaller one is the one that carries the small letter D. Okay? So that is the condition that you're given. So this is 254 millimeters, which we can simply divide by 1,000 to give us 0,254 meters. And the inside diameter, that is the small d, is 200 millimeters, which you can simply divide by 1,000 to give us 0,2 meters. And they are saying, if the compressive, because it's carrying that load, so it's compressing, okay? That's a compression. Compressive stress of the material is not to exceed. They gave us the stress. They gave us that the stress is not supposed to exceed 52 megapascal. It is just like the previous question that we had. The only difference is that what you are calculating now is the force. There, you had to calculate the area in order for you to have the diameter. So whether they know the type of force or you do not know the type of the force being applied, do not worry, guys. The formula is not going to change. This stress, for it to be calculated, force over area. So we need the force. So definitely I'm going to make F the subject. Okay, let's make force the subject. Cross multiply 1 times F. That's F is equal to the stress multiplies the area. So it's the stress times the area. So as you can see, in order for us to obtain the force, we need the stress, okay, which is given. We have that stress. The area we do not have. So we have to calculate the area. So where are we going to obtain the area from? That is from the hollow section that we are given this one. Remember, that's the hollow section. We are going to consider the area, like I said, pi over 4 into what? D squared minus D squared. From there, the area can be calculated. From here, the area can be calculated. Or you can just substitute as it is your formula here in place of A. Substitute everything. It's up to you. The way that you understand it. So that's pi over 4 into the diameter. The bigger one in meters. Remember our area in square meters. So the diameter, let it be in meters also. 0.254 squared minus the smaller one, 0.2 squared. So this is going to give you the value of the area. Like I said, your area, remember those decimals, guys. Those decimals for area, 0.0192548. This is your area in square meters, which you can just write as, let's just try 1, 2, 3. So if you move 3, we can just use 2 until the 1 there, guys. Just use the one that you're comfortable. You can move 1, 2 like this so that it can be 1,925. Okay, we moved to 2, 1, 2 times 10 to the exponent of minus 2. We can use this value as it is, guys. It's not even a problem. The way that you understand that, maintain that. Then with the area that you calculated, you can substitute now to determine the force. Remember, we need the force. We've already made it the subject. We already have that. So the force is equal to what? The stress given, the maximum that you're given, 52 times 10 to the exponent of 6 megapascal, times the area, 1,925 times 10 to the exponent of minus 2, depending with the way that you round it off. Your answers there on area, whether you use it as it is, still it's fine. So that was going to give you the force. So according to this one, it was going to give us 1,001,000 like this in Newton, according to this one, which you can even write to kilonewtons, or kilonewton, guys. Force monomally, kilonewton. So you can just get rid of the 3 zeros. Okay, divide by 1,000. So if you divide by 1,000 or if you multiply by 10 to the exponent of minus 3, you're converting to kilonewton. So it was going to be 1,001 kilonewton. So like I said, the conversions of your area will slightly make a difference on it, just a slight difference. So it is because of how you round off your values, answers that you're going to have. So we shall see in our next class the comparison between this stress that we have been calculating and also the strain. So that part is going to be on another class, working with the stress and strain and proceeding with these revisions till the question papers. So just make sure that you tune in for other classes and not forgetting the guys of membership who have allowed this to happen for us to have these tutorials. Actually, I was not having any plan to work with the strength of materials right now. That is because of the membership since last trimester. It was a request. So we just have to force to make this work for this trimester for our strength of materials N5. Then we're gonna see in the next coming one working with strength of materials N6. So for those doing N6, maybe you're just doing a recap. We shall see, guys. For now, I don't think we're gonna be able to work with that. We're just gonna maintain working with N5 until they're done for this trimester. Till we meet again.